Olá, todo mundo. Dentro de alguns minutos a gente vai assistir a apresentação do professor Wahong, da Universidade de Guelph, no Canadá. Professor, I'm going to present your biography in Portuguese, and then you start your presentation. You have 30 minutes for the presentation, and then Dr. Xiao will have 30 minutes, and then in the end of the presentation of Dr. Xiao, we'll have plus 30 minutes of questioning. Então, pessoal, o professor Dr. Wahong Yang é professor do Departamento de Geografia, Meio Ambiente e Geomática aqui da Universidade de Guelph. Ele tem desenvolvido pesquisas relacionadas à valoração de ecossistemas ambientais integrados a sistemas SIG e modelagem de custo de implementação de melhores práticas de manejo. Ele trabalha majoritariamente com programas de conservação, agricultura e tem várias aplicações em várias bacias grandes no Canadá. Professor, go ahead.
Yeah, thank you, Rodrigo, and it's what a privilege and for me able to share our research with all of you. Greetings from Canada, and I really appreciate the conference organizer and thank everyone for giving us this opportunity, and also looking forward to future connections. Specifically, we have our Dr. Rodrigo Miredo now is with us. He's just outstanding. I'm very happy, and he joined us, and we're going to conduct research collaboration with us. Okay. Without further ado, I'd like to share our research. And this is called a modeling. It's called IMWebs, and also called ESAT. It's a WebGIS interface. So I'm specifically going to talk a little bit about a study watershed, and we do this. We work on this for a long time, probably over 20 years. And so I will share my slides, and probably after my presentation, and with the conference organizer, and so that you are able to see it. And then some of the slides I will just move over, and I hope it's okay. So basically that's, and in North America, and there are many agriculture environment programs. So all those programs in Canada, in the States, Europe, and Australia, European Union, basically is this. It's agriculture, and the farmers have the right to farm. So, and agriculture, we know that it causes pollution, not necessary, and fertilizer, tillage, everything. And so government and typically provide a subsidy and to farmers and to do the conservation practices. So that being said, when they do those practices, one of the important thing we want to know is about what are the effects. And because when the government invests or other people invest, they want to know the answers. Say, we go to a store to buy a clothing. We want to know, what's the quality, what's the color. The same thing with conservation investments. We want to know the effects. So that this one I showed is the United States when I was working over there, and is that they have such a project and evaluating conservation effects. And the US has a lot of data and collection, and they have a crop field, and they collect a lot of data about what's this and what's the crop, what's the practice, so that I can put into the model. So that's about the US and the situation. And we are in the Great Lakes area. So, and this is the US side of Great Lakes. And so for all this type of like we're here, and then you see the blank because this is US research. So they are able to use model, which is called SWOT. Now, some of you know that is a SWOT model, able to say, okay, for this area, and what are the reduction of phosphorus? P stands for phosphorus, and what's happening now, and also what will be done in the future. So this will be very important and answers and which can help policymakers. So that's pretty much show the power of the modeling. So the same in Canada, and I was fortunate to be involved with this project in the beginning, is called the Watershed Evaluation of BMPs. Here, the BMP is a strange term, and basically stands for nutrient management, the tillage, those kind of stuff. So, and then again, and this is just across country, they have a different location and to do the study. So this is pretty much and what I'm talking about. And the government pay farmers to do those field strips, grass waterway, wetlands, and want to reduce pollutant to the water body. They don't want the water body like in our area will be the Great Lakes and a lot of pollution going on right now. So in this case, and of course, and the famous SWOT and has been applied, and our Rodrigo is the SWOT expert. So, but a SWOT and it's one of the models. Actually, is NUMP, like it's NUMP things together. It's called hydrological response unit. Say like in this area, they put them together. If they want to do buffer, it's one buffer, right? It continues, and then wetlands in a sub basin, and then they go NUMP together. We actually did develop some algorithm to NUMP them together because that's what the model structure about. But for our research, and about 20 years ago, we also applied SWOT and even applied the Canadian condition as our group. But we developed a cell-based or grid-based model, and from beginning in parallel to SWOT. But we borrowed a lot from SWOT, and also we developed our own algorithm. In short, this model is able to drill down to details. Suppose the cell size is 10 meters, you can go to 10 meters. And then for the buffer, you can go wide buffer, narrow buffer, it's no buffer here, it's fine. For each wetland, and they can go individual. So basically, it's just a grid version of the SWOT model. So it's more detailed. And then the same thing, there are many other models. Like I said, they have a risk assessment tool and the indicators. So those are important. But in comparing to the model, and we can be used is because this model and is a process-based, we're able to estimating and what are the effects of location-specific practices and what are the effects on water quality, water quantity. So that's the premises about that. And the indicators are important, and then we can rank location high and low, but we're not able to know what the effects are. So that's pretty much the difference. So this model, and like I said, is a cell-based model and based on grid cells. And then this is the only model in Canada, and that is designed for quantifying what quantity and quality benefits of agricultural BMP at a site, field, farm, watershed, and river basin scale, because they are able to drill down to details, so they're able to scale up, right? Gradually know the more large scale. And because this is a grid-based, so make it very easy to integrate with economic model, carbon model, biodiversity model. So that's actually my colleague and Dr. Shawn Xiao will show you a little bit later and about the interface and what we have done. So it's different. It's the same with other model, right? And there was climate, topography, soil, and all the information. But for this model, one of the key things and is that we need to know the information about what are the current, those BMPs, like wetlands and wetland buffers, cover crop, and everything. If we don't know those location information, we don't know how to estimate. The same with the feature scenarios. Feature, we need to know what are the potential wetland location, potential buffers, so that we're able to evaluate and the effects and for prioritization. So this model, and we do have a different time step, but mostly we are simulating by hourly. By daily. So the whole idea is that, and we are able to have an existing scenario, which is based on what historical condition. So after we set up the model, we remove all those existing BMPs, then we're able to see the effects. And also we can add on, so see what model simulation results looks like. So this is very typical of your research, and it's typical of what's done in the States and the United States and what we're doing here. So it's no difference, but the difference is that we have a model able to drill down to details, able to evaluate those effects. So up to now, and we have developed more than 30 BMPs. So this model is different from other flooding models. Some other model is that we make agriculture very complicated. You can see that it have crop, tillage, fertilizer, grazing, irrigation, reservoir, wetlands, and manure application. I'm sorry if you are not in agriculture, maybe this is strange to you, but that's pretty much agriculture. So we're able to cover most agriculture practices and like a buffer system and pasture management. And then so again, and I will share slides with all of you and after the presentation, and then I will not get into details. Just want to say this model specifically is want to make agriculture landscape and more realistic. So and in this way, and people are going to say, why this model is good, that model is good, and my view is always that all the models are very good, and but the model has a specific purpose. Our model and specifically is to examine evaluate the effects of agriculture practices, and also that has a very detailed resolution in comparing to the SWOT, famous SWOT. So what I'm going to show is that this is our Great Lakes area, and actually we're about here. We live here. So and then so this is Great Lakes, has lots of the pollution problem, algae, and then so we have a 3 watersheds, and we worked for a few years. And now I'm going to show you one is called McGregor watershed. This is the government Ministry of Environment funded project. So we do that. So this is not more than like as I said, it's very typical of the modeling process. That is about 218 square kilometers, and it's not that big, not that small, and they have lots of agricultural activities here. And just like any model, and we're going to get a DM and get land use and get a soil type, and again you see that almost 90% is agriculture. So this is actually our area is one of the, I would say, is one of the heavy and intense agriculture areas. So that's about typical data. Again, is not, we don't need to drill down to details, and for that I provided information slides is because maybe we can drill down some details if necessary in the future. So and then like any model, we get a climate data, and for gravity model, and we get a flow data and water quality data for calibrated validated model. So that's no difference with your research on the model setup on the calibration validation. Again, this is repeating, and what data we got, right? We get a stream network boundary BMP and waste treatment plants, because we can put that as one of the pollution source. And even that they have some pile drain, and the farmers want to drain the field and to get more crop out of it. So then, but you see that existing BMP is one of the very important and feature we have. We want to get the data. So we also have very good data. Actually, we have like LiDAR data, and we can actually go 1 meter even if we like. So we do have a different resolution of the LiDAR DM data. And then for this research, and then this one just want to show that the crop type and in this area mainly is corn, soybean, and wheat. And then right now, and forage, and which is more like a green cover, and it's gradually growing. So, but you see that, and they have like a decrease by certain acreages because farmers want to using more corn, soybean, wheat to make more money out of it. But this is why we need to do those kind of conservation practices. So that's pretty much trying to show a trend. And then again, and some of the colleagues may say, why you want that detailed? Because this is about agriculture. And so we make agriculture very detailed. For example, for corn, and which day is the seeding days, and which day is harvest days, and which day the like apply this fertilizer, that fertilizer, which tillage. So, and this is the same for corn, soybean, wheat. And in Canada, we're also fortunate. We have a long-term time series of the crop pattern data. So then we can populate this data together and to make the model more realistic. So that's about the crop. And with that, and that's what I talk about, so-called BMPs. And you see that it's not a lot, means that we still have lots need to be done, right? And so we want to know, and what are those kind of locations? Like for example, they did alternative phosphorus management. They did a buffer strip, right? And we want to know what the effects are, right? Not too many. So that's one of the things. The model can evaluating what's happening now and also simulating what's going to happen in the future. So that's the pattern. So we are able, just like any model, we're delineating the watershed. But one of the things I like to highlight is that we're able, like I mentioned about, we're able to go to, we finally decided to use a 30 by 30 meter resolution of cells, but we are able to drill down to details of those sub area, which is intersection. It's only about 2.4 hectares, which is very detailed. In that way, we know the location specific effects. So that's pretty much our setup, which is reflect what this model about. And then here, I'm going to move the slide quickly, and it's because you folks probably know what I'm doing here, and for that, it's basically we want to make sure the model is working. For example, here that we want to make sure the flow and you see the Nash coefficients and bias, everything is reasonable well. We have statistical measures. So that's the about the flow station, and then with sediments, right? And then sediments, and then we're able to simulating concentration and also loading. So we want to make sure they are reasonably okay. And you probably as a modeler will know that this is very challenging, but we try our best. And then for the phosphorus, and this one actually is nitrogen, and PM means particulate nitrogen. So we even go down to the level to look at the particulate and the nitrogen concentration and the loading. So that's, again, is not my intention to go to the details. And then you see the dissolved, DM means dissolved nitrogen. And this, dissolved typically causes more problems. So then we did a simulation, and then we put together total N, right? What the effect looks like. So that's how our model able to drill down to the specific pollutants and into details as well. So in our area, phosphorus actually is one of the important problems and cause a lot of issues for particulate phosphorus. So that's the again is less harmful, and but dissolved phosphorus and it's going to cause problems. So we calibrate everything, and about that later, of course, finally we calibrate total phosphorus. So that's, again, I'm sorry that I move very quickly. Just want to say we did our job and in detail about all this model. So after the model setup, so lots of time, and we're able to say, oh, okay, and this watershed under existing, when I say existing means the historical, this is 25 years. We want to know, average precipitation, and looks like what's the flow out, what's the surface flow, what's the tile flow, ground flow, sediment loading, everything we put it here. So right now this is summary, but because our model is very detailed, we're able to drill down each location, which is Dr. Shawn Xiao will show you about those potential to look at those results and in details. So the thing is that this is the starting point for us to starting to do simulations about BMP effects. And I always say that, and a well-established model, and it's just like a laboratory. We can use that laboratory and to do experiments. So that's the situation. So show some spatial results, just like I say, you see that actually we showed the field level, but we can even go to the more detail level. We can show surface runoff, and that it's different. You can see that. And TSS means sediments and total suspended sediments, and it's not the same pattern, right? And for that, so that's how the spatial and the prioritization and the spatial differences matter. So that's the model, and we talk about it. How to prioritize the location to do those conservation investments. So that's the model can help to do. And then we can also look at what's the phosphorus and what's nitrogen. That's what we'll talk about. We can even drill down to details. So the whole point is that even for different pollutants, the pattern are different. Like phosphorus and nitrogen are different. But the government we're going to say, oh, let's focus on phosphorus because the phosphorus and that's the serious problem right now. So all the things we can look at spatial resolution, we also look temporally each year, even by day, right? Because the model simulation is by day. So that's after that, and then we're going to run scenarios. So we have a baseline scenario, and then we're in Canada here right now in our area we do cover crop. Cover crop is just those green cover like a forage and alfalfa those things, just make the land more covered by green space, not have a lot too much sediment. They have a nutrient management, basically they mean to reduce fertilizer. And then buffer means that they put buffer over the stop and pollutant. Marginal land means that those kind of low yield area is very exposed to the exposed soil, so they can restore that. And then wetland, of course. And so those scenarios can help us and to know what the future effects looks like, and also that existing BMP can help us to show and what the effects are. For example, and this slide is just trying to show that and those existing practices, and we're able to know, oh, sediments they reduced by 0.45 and tons per hectare. And then we also have economic numbers. We know what the cost looks like. And you see that the costs are different as well. For the same nitrogen and phosphorus, and you see the costs are very different, and it depends on different crop, right? Different conservation practices. So that's good thing. Good to know. Good to know which one is better and which one is more cost effective. So that's pretty much some of the things, and we did. Again, those numbers per se, and is not that important for today, but the numbers actually going to matter when it comes to decision making, right? And this one can actually provide accounting purposes. Say, hey, I invest how much, and and what do we get out of it? So that's about the practice, and also that, and we also talk about that for scenarios. So this pretty much just say in the future, if we have those scenarios, and they are going to, like I say, they are able to do almost 15,000 hectares of cover crop and 18,000 hectares for nutrient management. But for buffer, yeah, that's not going to be a lot because the buffer is narrow strip, right? And wetland the conversion and restoration, because we all have some algorithm to identify wetland location. So later on, they are able to tell, oh, if all of them will become like conservation practices, and what the effects looks like. Of course, we know that will not happen, and then, but at least we know the pattern looks like, and we know what the spatial location looks like. So we go from there, and then later on, and they, of course, they are able to even do some ranking and about that. So which one and is more effective, and by per area, and you see that the ranking is not the same. And some of them almost the same, 1, 2, 3, and looks like almost the same. Means they're pretty close in terms of per hectare and of the effectiveness. But if we look at the cost effectiveness, we'll put the economic cost over there. You see that a difference. You see the 1, 2, 3, and then is very different from what we just look at the biophysical numbers, right? And then put the economics in, it's changed again. So these things, as a researcher, and our job is not to tell government decision makers what to do. We are providing a model, and they are able to look at different scenarios and different options and see what they can do. So that's pretty much what we the meaning of our research and to do that. So, and then furthermore than that, and the model we developed did not have the carbon and biodiversity components, but we're able to couple some of the other models and get some information, able to put that data into this watershed. And let's say, you see that again for carbon, probably know that now the carbon market and the sequestration, carbon sequestration is very important. So that's about the carbon data. So, and for us, I like to almost done here. Just want to say we do have IMF model, but also that ESAS is Ecosystem Service Assessment Tool, is because people always tell us, say, your group did modeling, oh, that's pretty good, but it's too complex, and we don't know how to make use of it. And can you make it more easy for us to look at it or something? So that's exactly idea. Actually, is Dr. Rodrigo Moreno, and introduced me about your folks project, and in Brazil, it's very cool, able to build a WebGIS interface to show people, right? So that's what Dr. Shawn Xiao we're going to show you a little bit later. And then, but what's our purpose of doing this modeling? We want to evaluate the performance of those existing on-ground projects. What are performance, right? Is like I invested $1 million, and what our effects looks like. And even more than that, we want to know and to achieve certain environmental target. For example, in our area, for the Lake Erie, like the Great Lakes, they set up a 40% phosphorus reduction. And can somebody tell and what level of conservation investment, how many and the practice we should do to achieve that goal. And I would say only a model can answer this question, right? And because it's very complex and for that. But also that we need to prioritize the location and to say where we should do those kind of practices. And then another thing is that, and we have a city. City has like a waste treatment plant. Are there any trade-offs? And say we do more agriculture practices, and then city waste treatment plants don't need to upgrade a lot because it's very expensive. And can they do? Model can do the answer those questions. Also, we're interested is that because a lot of organizations tell us the model is too complex, we're not going to hiring a modeler in your organization. We're interested about that to put a modeling and as a service to people, and so that they have access to that. And we're not talking about charge a lot of money. We just want to cost recovery. So we have a few researchers here. Can we provide modeling service to 100 organizations, right? And in that way, and able to have access to modeling and get some good benefit out of it. So that's pretty much some of the ideas behind. Without further ado, actually, I look at the watch, and I know that, and we're going to take a little bit of time to set up. So I think I will finish, and basically that, and Dr. Shawn Xiao, we're going to do is going to do demonstrating a WebGIS tool, and but a WebGIS tool is not directly to model, because you probably know model is going to run for a long time. We just run the model for numerous all possible solutions and put it in a giant database, and then we use that for decision making, for visualization. So that tool can be used for explore watershed conditions and assess existing project, what a benefit, and also what a feature, how to target, how to prioritize it. So it's similar to what I showed you, but it's just in a more user-friendly way, more like a WebGIS way. So that's about our work. So again, I want to thank all of you for giving us the opportunity to present to you, and also thanks to conference organizing for allocated time, and thanks Dr. Rodrigo Miranda and for supporting us in the process. Thank you all very much. Thanks. Back to you.
Professor, thank you very much for your presentation. If you please kindly stay in the room for questioning after the presentation of Dr. Shawn Xiao.
Sure. I can stop here, right?
Yes.
Okay. Yeah, I think I stopped. Okay.
So we're gonna have the presentation of Dr. Shawn Xiao now. Dr. Shawn Xiao, I'm gonna present your biography, and then you have 30 minutes for your presentation, and after that we have more 30 minutes for questioning to you and Professor Wahong. Thank you very much. Pessoal, novamente, bom dia. O Dr. Shawn Xiao, ele tem toda a formação voltada para modelagem hidrológica. Ele tem graduação e doutorado em conservação ambiental do solo e da água. Ele é pesquisador associado do Departamento de Geografia, Meio Ambiente e Geomática da Universidade de Guelph. Ele tem expertise em desenvolvimento de software SIG, desenvolvimento e aplicação de modelos hidrológicos integrados com modelos de valoração ecossistêmica, voltados para bacias hidrográficas com áreas de agricultura e áreas naturais. E ele tem aplicação também em desenvolvimento de interfaces gráficas, e ele é muito, assim, a principal motivação dele é desenvolver ferramentas amigáveis que possam ser utilizadas para modelagem e conservação da natureza. Ele trabalha tanto com como posso dizer, agentes de conservação ambiental, como também fazendeiros, para melhorar o uso da água e melhorar também o meio ambiente como um todo, utilizando técnicas de conservação ambiental, como, por exemplo, corredores ecológicos e etc. Okay, Dr. Shawn Xiao, can you start your presentation? Thank you very much.
Sure. Thank you very much. All right. So I think everyone should be able to see my screen. as well. So first of all, my name is Shawn Xiao. I'm a research associate working at the University of Guelph in Ontario, Canada. So I would like to greatly appreciate the invitation and this great opportunity to share our research with you guys. And thank you, Rodrigo, for your introduction and all the organizers from the conference. And thank you, Wanhong, for the introduction and also our slides as well. So first of all, let's tell this story. Over my career, our team has been asked a lot of times about why should we invest on agriculture best management practices, or BMPs in short? What are their environmental benefits? Where and what BMP should be invested in the farm field in the future? When I heard all these questions, I tried to answer them with the most relevant and accurate number in our modeling reports, but I failed every time because those reports are long and only a few people have read it. So today, I'm going to share with you 3 quick demo cases with a web app which can answer these questions more quickly and effectively. Let's get started. So this system or this web app is called Ecosystem Services Assessment Tool, or ESAT in short. So I'm going to use these 2 names interchangeably. So this is a web app. Actually, this is a web page. When you come to this page, you need to log into the system. You need to have a registered email address and a password for protection of your privacy. So I already put it here. Let's get into by clicking on the sign in button. So let me hide this panel. First of all, let me introduce this watershed. It's called McGregor Creek Watershed. So it's within Ontario, Canada. Let me just zoom out a little bit and use the map. So you can see this is Canada, this is US, this is Toronto, and here is our watershed. Let's get back to this satellite image. So this first demo case is called Watershed Overview. This page is specifically designed to help the users quickly navigate through the watershed and get some sense about the watershed and maybe find the hotspot, the major concerns of where you should apply your conservation programs, or BMPs. So as Wanhong mentioned, I'm sure most of you have heard this presentation about the MWEBS model, or Integrated Modeling for Watershed Evaluation of BMPs. That is the engine for generating all this data. So this ESAT tool is actually just an interface linking between the modeling results and the end user, help the user to get most out of this modeling efforts. So, and that's why most of the tools you are seeing here are just filters to help you get a more focused view on a specific angle of the model to help you understand what you are looking at and what is the what environmental benefits can be brought by the BMPs. So let's first look at the top left corner of this interface. So there are several tools developed here. So first one is called the baseline tool. We have developed 2 baselines. One is called existing baseline. The other is called conventional baseline. The existing baseline is basically to use the model to mimic what is happening right now in this watershed. If you have already restored a wetland in your watershed, it will simulate that. If you already applied conservation, conservation tillage or fertilizer management, it will simulate it to mimic the status quo of this watershed. On the other hand, the conventional baseline is to remove all of your existing BMPs, your conservation programs, and to form the conventional baseline. So in this demo, I'm going to use the existing baseline for our demonstration purposes. The second tool is called spatial scale. There are 6 spatial scales implemented in this interface. LSD stands for legal subdivision, which is a widely used spatial scale or field boundaries in Western Canada, parcel, widely used across Canada, and farm level, municipality, sub-watershed, and watershed level. So our model is simulated in cell-based or sub-area based, so we can easily aggregate in different spatial scales. The third tool is called time slide. So it's this slide bar. It's basically we simulate the watershed from 1995 to 2019 with 25 years of daily simulation results. And we, we aggregate the results into yearly level. And so this slide bar, you can drag and drop the slide bar for the interface to extract the specific starting and end year results and aggregate them into yearly average results. So this is the slide bar, what this is used for. The last but not least is called color ramp tool. We'll come back to this one a little bit later. Next, let's look at the table down below here. So the first column of this table is called parcel. It's an internal ID used between different components of the interface. For example, if I click on this parcel number 1, the map will be zoomed into this the specific parcel, and the table will be highlighted so that you know what number you are looking at and what's on the map. For example, you can see this parcel is about 2.1 hectares with an average elevation of 181 meters above sea level, and etc. So this is basically a synchronized interface, so you can see anything from the map or the table, which makes more sense to you. And so let's get back to this table here. And the table here actually lists all the data we collected and simulated so that we create a data-rich environment. You can get most of it from our interface. And for example, we have the area of the parcel, average elevation, average slope, dominant land use, dominant soil texture, precipitation, those climate data, and also the modeling results like the runoff, sediment, and total phosphorus, and different forms of phosphorus, biodiversity, and soil carbon. So we simulate all of them and collect all of those data and put this into this table. However, if you feel the same as I do, because I feel overwhelmed by this data, if I look at this data, I can hardly draw any conclusion from it. You are not alone. I feel the same. So actually, you will find, if you feel this way, you will find this color ramp tool very useful. So what this tool does, it takes one column from this table and projects it onto the map. For example, if I select the elevation, it basically, the interface picks the elevation column and project it onto the map and use color coded to show different value ranges. So in this interface, red means absolute higher value and the green means absolute lower value. And in this case, actually, you can see this east side of the watershed is higher in elevation and the west side is lower in elevation. And you can see here, this is the Watershed Offset before it joined the Thames River in Ontario. And we can also project our dominant land use to the watershed. And from the legend, we can see agriculture is in yellow. So actually, majority of the watershed is used for agriculture purposes. We can also show, like the runoff distribution within the watershed. You can see some of the parcels has more runoff generated than the other because of different soil types, because of different climate variables. And we can also show, like, for example, the sediment, the erosion distribution within the watershed. And we can see also show the total phosphorus distribution within the watershed. And you can see the total phosphorus distribution share a lot of common hotspots with erosion, because majority of the erosion is majority of the phosphorus from attached form and some from dissolved form. And this map can help you to find where are those potential problematic areas, or we call it hotspot area. So you can strategically place your priorities in this concerning area and place more high priorities for those areas for more BMPs or conservation programs. So for this very quick demo about this watershed overview tool, we navigate through this watershed, and also we get a sense about how we can use this interface to get the hotspot or major concerning area of the watershed for different environmental concerning variables. So this is the first demo case. And the second demo case, I want to talk about existing BMPs. 9 out of the 10 times when we're walking to a conservation agency or authority, they always told us, like, we have invested a lot, like $100,000 last year into this watershed for conservation practices like BMPs. And can you tell us what are their environmental benefits? So this is a typical existing BMP environmental benefit quantification project. So in order to show the results, we need to create a project. So a project is simply a more focused view of the giant database and what has created. So we need to define the specific baseline, specific spatial scale, and the data and the year range we're going to evaluate the BMPs. So I already created one this morning based on existing baseline parcel as a spatial scale, and all the 25 years data is used for this project. Let's get into it. And if I click on this baseline information page, and you can see it's a very similar page as our watershed overview page. However, there are additional components here to show you existing BMPs. Let's look at the baseline BMP summary table on your right-hand side. So you can see there are 4 rows here. ISWET stands for isolated wetland. CVCR stands for conservation cover crop. For FERMG stands for fertilizer management, and the RIBUF stands for riparian buffer. It's a 10-meter width riparian buffer. So there are this many of parcels already implemented this BMPs, and these are their total areas of BMPs implementation. So let's look at the left side. If we want to look at specific BMP, where they are, and we need to go to specific BMP page, let's click on the CVCR page under BMP scope and intelligent recommendation tab. So if I click on that, the interface will bring us to this cover crop page. And on this legend, we can see this gray boxes are existing BMP locations, and they are actually here. So we already worked on this watershed for some time, and we know, like, here there are some cover crop already implemented in this field, and some other areas like here already implemented cover crop as well. So this is how you can find the existing BMP locations from ESAT interface. And how can we know their environmental benefits? We need to get back to this baseline information page and look at this BMP effectiveness summary table on your right-hand side. And this table summarizes all the parameters, the watershed parameters, and also the baseline value and the benefits brought by this baseline BMPs. For example, if we look at the sediment in this watershed, annual erosion rate at the edge of field is about 13,000 tons per year. And because of all this existing BMPs, we have lowered the erosion by about 17 tons, which is not a lot. But because we didn't implement a lot of BMPs in this watershed, if we do more work, do better work, actually, we will bring the erosion or other variables down because of the BMPs. So this is a very quick demo case about existing BMPs, how you can find their how you can find where they are and their environmental benefits. The last but not least demo case I'm going to show you is called intelligent recommendation. This tool we developed try to answer specifically 2 questions we were asked all the time about conservation practices. They are like, for example, sometimes we were asked about, like, can you tell me if I want to reduce like 10% of total phosphorus loading in my watershed, how should I do it? That's one type of question. On the flip side of the question, on the other hand, is like, okay, we already got the approval of a budget for like $100,000 for this year in this watershed. Can you tell me how should I spend this money wisely on BMPs if I care more about soil carbon, erosion, and maybe total phosphorus reductions? So these are two types of questions we try to answer with this intelligent recommendation tool. We name them as two different modes. Eco-service mode basically is like you know what you want to achieve in terms of environmental benefits, and you want to achieve this with the minimum cost. That's one mode, eco-service mode. The other mode is the budget mode. It's like you have a fixed budget. You cannot exceed this budget, but you want to maximize the impact of this money implemented, so spent on conservation practices. So that's the budget mode. So today I'm going to use the eco-service mode for demonstration. I already created two environmental targets. I want to reduce about 10% of total phosphorus generated from agile field. And I also want, at the same time, I want to increase some soil carbon sequestration within the watershed by about 1,000 tons. So these are the two environmental targets I want to achieve. And so by clicking on this Run Intelligent Recommendation button, what the system does is like it goes to the database and find all the possible combinations and solutions and finds the cheapest one to present to the user. So and also wants to achieve these two environmental targets: 10% TP reduction and also 1,000 tons of soil carbon sequestration increase. So if I click on this BMP selection and overview page, well, we can see the results from this intelligent recommendation. So let's first of all look at this effect in the summary table on your right-hand side, and let's look at the TP on site. Actually, by giving this solution, we can reduce about 9.98% of total phosphorus. That's very close to our target, and increase about 1,007 tons of soil carbon. So that's the benefits we'll bring. And of course, we have also reduced total nitrogen, erosion, and runoff, and bring biodiversity and soil carbon up as well. So that's the suite of ecosystem services because of the BMPs we're going to implement. So what are this solution looks like? You can see, look at this BMP summary table. This table basically summarizes all the recommended BMP to implement in this watershed in order to achieve all these ecosystem services. So for example, it recommended about 2,458 hectares of cover crop in 1,113 parcels. And so where are they? And the total cost for this BMP plan is about $377,000 per year in this watershed. And the distribution of all these BMPs are shown on this map. So for example, this pink parcels are basically all the fields or all the parcels the system recommended for cover crop, and for this, this dark blue ones are for riparian buffers, and those pink ones, this purple ones with an M stands for multiple BMPs recommended. So for a specific field, actually we have more detailed recommendation. For example, for this particular, let's look at one of this one. In parcel number 110, actually we recommended for 2 BMPs for about 1.6 hectares of cover crop and another 1.6 hectares of fertilizer management. 2 BMPs applied at the same field. And the total cost per year within this particular parcel or field is about $344 per year. So that's the recommended solution to achieve this goal of ecosystem services. However, if you look at only here, it's very intuitive already, but we found it's missing one thing about this conservation practice or conservation plan. It misses the human connection, because like this is, if you look at this software, it's just a computer based on numbers that give recommendation. It doesn't have any human activity, human connections at all. It doesn't know the watershed better than I do, and definitely worse than anyone who worked on the field. That's why we make this solution as just as a starting point for BMP planning. So for example, if you click on the cover crop page, actually it brings up all the recommended fields with cover crop. But at this point, actually, if you ask the farmer who work on this field, maybe this farmer doesn't like this BMP at all. Then in that case, you can check this out, and actually the interface will update all of this, plants and the BMP effectiveness on the fly. And you can actually, if you want to add some fields into your planning, you can do so by just click on the map or click on the table as well. So you can see all of this tables and all of these summarizations will be updated. The cost will be updated. The environmental benefits will be updated. So all of this will be updated accordingly to according to your actual planning. So basically, with this tool, with this ESET tool, you can build a applicable and practical BMP solutions for your watershed. So yeah, that's also almost all my presentation, but at the end, I also want to show you some other functions we bring to this interface so that it basically make it easier to use. For example, for this automatic reporting function, we can generate a report and download it as a Word document, PDF, or other different formats, and you can see all the settings and all the all the results you have been seeing on this watershed, on this interface, and the BMP recommendations on this interface can be exported as a Word document or other different electronic forms. And that's one function. And also, we try to make our interface as open as possible. And so actually we have developed this export function. So when you click on this, it will basically export all your selections of BMPs as a shapefile so that you can open in your own GIS software. And so you can build your own maps and present your own way. So, and all the data you are seeing here, all the costs, all the environmental benefits will be exported with that shapefile in the attribute table. So we try to make our tool as open as possible at the same time. So to conclude my presentation, this ESET tool is an emergent tool. It will have more BMPs to the coming and also more features in the future. But most importantly, we are building this tool to be used. It's like if you have any recommendations, any interest for this watershed, please feel free to reach out to us. We're happy to give you another presentation or include the functions if it makes sense to us. Okay, thank you very much, and I will get back to you.
Thank you, Dr. Shawn Xiao, for your presentation today. It was very interesting. Now we're gonna have 30 minutes approximately of questions. Pessoal, a gente abre agora a sessão para perguntas, comentários ao Dr. Shawn Xiao e ao professor Wahong Yang. Thank you. Professor Yang, Nara is thanking you for your presentation, and I'd like to ask you if you have plans to simulate the impact of future climate scenarios on crop evapotranspiration and ozone flow and water allocation for growth crops in the future.
Yes. Yes. Can you hear me?
Yes.
Yes. Okay. Thank you so much. This is such an important question. Actually, this is a question very important, also being asked by many stakeholders. Say, and you simulated historical condition for 25 years. How about the future? So climate change is so important, And in Canada, they're going to have a more warming climate and maybe less precipitation and more extreme, and going to cause agricultural activities going to be changing and cause lots of other problems. So, in short, we will, and actually we have to. And actually, it's, just in Dr. Shawn Xiao and I were investigating new projects, and the project guidelines specifically ask us say, can you put the climate change, not just us, like anybody, and put climate change into it. So we do plan to put a climate projection into this analysis in the future, and for simulating watershed process in detail, and also simulating potential effects of conservation practices. See that how down the road in 10, 20, 50 years, and what things will look like. And yes, actually, it's one of the things in Canada, and I'm not sure in Brazil, and is that climate projection data is pretty difficult to get because done scale from global circulation model is not easy. And but I would say, and the researchers, government has done they have done lots of work, and fortunately that in Ontario, in our province, and we do have next say close to 100-year projection. Actually, with pretty good resolution. I think if I'm not mistaken, it's about 25 kilometer or like kind of a grid resolution for us to simulating, which fit into our model and very well, I would say. And in other provinces, and I'm not exactly sure, but I think Canadian federal government also had some significant efforts on that. We will do that. Thank you so much for asking that question. Yes.
Professor Young, sorry, I was mistaken. The question was from Professor
Okay.
Magna Moura.
Okay.
Okay,
Thank you. Did I answer? Did I miss anything? Did I miss anything? And then you let me know. And
okay.
it's about climate change, right? It's about climate change, not about. Okay. Thanks. Yeah.
It was about climate change.
Yeah. Okay. Thanks.
Uh, I also have a few questions. Through research projects, if anyone would looking for modeling tropical areas using iModels, what would be the minimal requirements for regarding inputs of the model?
Yeah. Thank you. Wow. I'm very, very thankful for all those so insightful questions. Actually, as a modeler, and I always tease myself and say we're data hungry, and it's difficult to get those data we need, and it's always challenging. My philosophy is that we wait for 5 years, 10 years, 20 years, 50 years, data is never be enough. So let's do it. So that being said, and then minimal requirements will be that, and for that, and it's a few data sets. I would say first one is topography, DEM. And if you really cannot get good data, and why don't we get global DEM data? Just start, right? And to do that, and then land use, right? And then again, satellite imagery, and for that, and then soil. So this is the three key landscapes. Of course, the model will be driven by climate, and then with simulating, we need a flow and the water quality data to calibrate. I think that's the minimum. However, I can say that not every place has the data, but I would say climate, topography, land use, and soil, that's the minimum. And why you say a flow water quality is not and the minimum is because I even in some of the watershed in Canada I work on, there's no flow data, no water quality data. So what I did is I do some flow transfer analysis and then make sure the model is working because we don't want to wait for 5, 10 years people to do those work. And this model is not different from other hydrological model. Its data requirements are very similar. But my philosophy, like I would say, I really appreciate this question because we always, actually, this is a question also people ask us a lot. Say, it looks like you have very lots of data. And after those minimum, I can tell you how things work is because we make assumptions. For example, for agriculture management, and we need planting dates, harvest dates with everything, right? Sometimes we don't have the data, we survey farmers or something, but we can also make assumptions. We can ask experts, say, oh, does this make sense or not? We can do those, make those assumptions to make those things work. And also that, of course, go to Google, some other source, try to get more data. So that's my answer. Thank you.
Professor, we have a question for we have a question or comment from Paulo Lucio. He's saying, what about developing a similar system in a pilot project of implementation in other states? What do you think in developing a similar system or in a pilot project of implementation in some states of Brazil and extend to whole Northeast area? So I would like to extend his question and ask you, what do you think would be more challenging for IMWeb since it was developed from Swati to specific to some of the features we have here in Canada?
Yeah, thank you. Thank you. This is such an insightful question. I feel so happy about that. I have to admit, and we live in Canada, and we developed this model specifically for Canadian conditions. So, and for example, in Canada, it's very cold, and we have a frozen soil, snow, and all the things. So we put lots of efforts into those algorithms. However, when we developed this model about 15, 20 years ago, almost 20 years ago now, and then we specifically developed this model as a modular system. What that means that we have many, many compartments like a precipitation, interception, and and the evaporation, and all this kind of a flow generation sediment is modular. What that means that each module and is a component we connect together, but within each module and we have different options. You can choose this method, that method, for doing that. That being said, in my view, and IMWebs is an open system which is able to be applied in Brazil, but it's not necessarily is our efforts. Is expert in Brazil, right? You folks are great in doing that. Is that maybe you're going to replace some of the algorithm we developed? Say, oh no, that's not good. We're going to use our Brazil condition and something like that. So I really, and this is the purpose of today's presentation, right? And we're hoping this is the starting point and for the collaboration. And I have to say, and when Dr. Rodrigo Moredo and connect with us, I was so happy. It's because University of Guelph, and we have actually quite a bit of connection with Brazil institution, and we're so happy for doing. Right now, it's not very active, but I'm pretty sure in the future going to have more opportunities. In short, we're willing to open this model and in a structured way, and later on, Brazil researchers may be able to take it on to develop and apply to certain conditions. We can also even do some test runs. One of the things for us is the most challenging is about our time. So we're very limited in time. We struggle to get get funding and get a group going with everything, but just like anybody. So but that's definitely a good opportunity. Maybe we can apply from joint funding somewhere and starting some work that could be possible too. Yeah, I think it's very, very important and insightful question, and really appreciate it. Yeah, thank you.
Thank you. Dr. Xiao Xiao, uh, I have a few questions for you too. Uh, do you think ESET could be used to select and plan areas for environmental protection?
Sorry, can you please repeat the question?
Do you think ESET could be adopted or used to select and plan areas for environmental protection?
Yeah, of course. I mean, so it's all based on the MWeb's modeling results, and as long as we can apply the MWeb's model in a calibrated environment, and also with proper process control, like we can build the model in a proper way, and we can definitely build in more scenarios and in terms of different BMPs and show them on ESET. So technically, that's not a problem.
So may I add on it? And as like Shawn Xiao and I said, I always feel in my career, I feel that and our modelers, and it's pretty isolated from users, and the user not able to make use of them. So I would say this WebGIS interface is a starting point. We really want to make those results useful by people. We don't ask them to have lots of technical knowledge. That's not fair to them. They should not know too much about detail about model. And then I do know that and this interface is still complex, needs some more training with everything. You know what? As long as people get used to it, people can do that. And we're hoping because this is a web interface, and we store this one in a Microsoft Azure, and we purchase cloud. And we hope that when people doesn't matter where they are, they can have access and able to to make use of them. Thank you.
Thank you. Dr. Xiao, do you think do you have plans to upscale ESET to other countries? Uh, what do you think would be your plans for future? Like upscale a single interface globally, or to how can I say to uh, deploy ESET to other countries, have their own services and use it as their own their own programs.
Yeah, I think that's a great question. Actually, I mean, first of all, like ESAT is one interface we have been developing for showing environmental benefits of different BMPs. And first of all, it's the initial idea of designing this interface to help conservation managers like you can adopt this modeling results quickly. And of course, in the future, we are also considering use more different type of interface targeted for different type of users. For example, actually, I did a show today is about one farmer system. So basically, it's used for it with a more focused scope, like within one farm, based on the farmer, and the data will be richer in terms of the farmer's view, but less intensive in terms of a watershed view. So yes, to answer your question, I mean, I don't think it is going to be one interface feeding to all different type of users, but there will be, but the backbone, like the modeling results, will be the same, will be shared, but it's just specific target for different users. That's my first point. And second point, I think for the deployment, well, this is the reason why we collaborate with Microsoft, and Microsoft Azure is implemented in different countries, and so I think it should technically it should be available for us to scale up for different countries, and just but of course we need to have adapt our interface and into different countries, language and the cultural requirements, those kind of things. But I mean, I think just to answer your question, first we do plan to have different type of interface for different users, and secondly, and with the current setup, we are scalable for different countries.
Yeah, I just want to add a little bit on it, and this is some of the new things to us as well. And because as a researcher, we get used to working in office and publish and and don't know the user needs. Actually, we are going to make effort to understand what the user needs, and we do have made lots of friends and in the government, different agencies, and just like Shawn said. And this is the starting point, and actually it's quite fresh. This interface is just only a few years old, and we try to scale up and have a more engagement with people, and also develop multiple products. And because this could be like a backbone and have a different spin-offs, and definitely, and we are interested to apply into other countries for sure. And for that, and just like I said, and the model itself, science is pretty open. It's not something secret. And we have lots of experts today, and audience. I'm pretty sure you have lots of accomplishments. But hopefully this kind of interface can be more like a translator, translate our knowledge and into the users. Like Dr. Rodrigo and Miranda and they showed me about the Brazil interface and for extension to the in Brazil. Oh, I said it was almost the same idea. It's great. We'll have these things. As I said, I honestly say that, and we are just part of it, right? And you folks also have great accomplishments, and hopefully in the future we have more exchange. And specifically right now, and due to the pandemic, and I can only imagine I travel to Brazil to give a talk, but now we can talk in our office. which is great. Thank you all of you very much. Yeah.
Thank you, Dr. Xiao. Thank you, Professor Wahong for those interesting presentations today. Just one final comment, and we will finish here. Professor Joseph Leda say he's looking forward for a great partnership with Brazil. She is very interested in upscaling ESET and IMWebs to Pernambuco.
Thank you so much. Thank all of you. I really appreciate that. And also best wishes to all of you. Thank you.
Thank you.
Thank you all.
Yeah.
Obrigado a todos.
Bye. Yeah.
I know.
Água é vida. Grande parte do nosso corpo é feita dela, mas isso todo mundo sabe. O que nem todo mundo sabe é que a APAC, Agência Pernambucana de Águas e Clima, faz bem mais do que emitir os essenciais boletins de previsão de tempo. Mas, afinal, o que a APAC faz? Cuida, planeja, monitora e fiscaliza o uso da água. Fiscaliza as barragens, garantindo a segurança dos cidadãos. Protege as nascentes e margens de rios e riachos em assentamentos rurais. Oferece incentivo aos produtores rurais que contribuem para a proteção e recuperação de mananciais. Incentiva projetos que recuperam e protegem as nascentes e mananciais. Apoia a gestão participativa por meio dos comitês de bacias hidrográficas e conselhos de usuários de reservatórios. Trabalha para garantir o direito à água. Monitora os recursos hídricos e está também sempre alerta e pronta para comunicar à Defesa Civil e à população o risco de cheias, chuvas fortes e secas. APAC, nossa água, nossa missão.